Hopefully you can hear me. Hello, everyone. Welcome to another edition or another class of our Aquarium Online Academy. My name is Amanda, and I'm coming to you live from the Aquarium of the Pacific in Long Beach, California. And I am joined this morning by my friend, Miss Carrie, who is going to be sitting at the computer and answering or relaying to me any questions or comments, observations that you have during the class today as you participate along with us. And I also am joined in the studio here where I am by my friend Miss Jen, who will be controlling all of what you're seeing behind me. I'll be controlling some of it, but she'll be helping you be able to see what I have in front of me on an iPad that I'll be using for this class. So this class is going to be a little bit different. It's called Discover Earth. So we are going to be exploring our Earth. Now, when we think about our Earth, we think about land and sea because those are the obvious things that you can see when you look at it. But what I want you to do is make some observations of your own. And we're going to have the opportunity to explore the Earth by using extra technology. I have an iPad in my hand. We're going to be using a program called SOS Explorer. SOS stands for Science on a Sphere. And what we're doing is we are basically looking at the Earth as a whole as much as we can while we're standing in one place on the Earth by kind of flattening it, but making it look three-dimensional. So you notice right here, we have a picture of Earth, and even you can see a little bit of space represented behind it. And we're going to make some observations on it as much as we can, making it look three-dimensional. So we'll be able to spin it around a little bit. And anyhow, let's do some exploring. So I hope you're ready to explore with me. And when you have questions and observations, go ahead and use that line that you see right here. The live questions you can text to 562-286-1838. And if you're watching this at a later time, while it's not during our program at 10 o'clock on Friday morning, you can just email us any questions you have at live@lbaop.org. And one of our educators will be happy to get back to you. So welcome. Let's go ahead and get started. So as I step out of the way so you can see this a little bit better, I would love to hear what your thoughts are on what kinds of things we can observe from this. What can we learn about our Earth by looking at this image? Now, we can observe some things, but how can we learn about it? Well, let's go back to how we're getting this image. I want you to think about where this image is coming from. Is this an actual picture of Earth at this very moment in space right now? Think about that. And what can you see here that would tell you whether this is a live image of our Earth right now in space? What kinds of things would you need to know? Well, first of all, we can think of the point of view that we're getting. So how would we get this image? Well, obviously, this is something that's looking down on the Earth. So what might be out in space that could be looking down at Earth giving us this image? Is there something up there now? Is it someone taking a picture with a photograph, with a camera? Or is there some other sort of camera giving us this image? So think about how we're getting this image. And then I want you to think about what would be the next clues that would tell us whether it is a live image or not. How would you know if something is live? How would you know if a picture of the Earth is live? Oh, Oscar is saying that Oscar sees clouds. Now, what tells you that you're seeing clouds? Because I think about clouds being up in the sky and I don't see anything around this area. But you're right, if we're looking down here, there is something that resembles clouds. How did you know that the parts that you're looking at are clouds? Because there's also some basic information there that we probably need to know because we're going to be using that as we look at some of the things in this class today.
Oscar says the Earth is not moving and the Earth is always rotating, and we're getting some responses of satellites.
Excellent. Okay, so a lot of you are responding that satellites are giving us these images, and you're absolutely correct. We're getting this image from satellites out in space and sending us this information. But then also Oscar said, well, wait a minute, it's not moving. I don't see anything moving. You're absolutely right. But of course, Earth seems to move kind of slow. But you're right, there's something else. It's not moving at all, is it? And when you mentioned the clouds, how did you know that they were clouds, Oscar? I want to know. How did you know that we're not just looking at something out in the ocean here? What is it? Because there's some basic information here that we can gather about the Earth. I want you all to think back to the basics. How do you know if you're looking at clouds or if you're looking at land or if you're looking at the ocean?
Oscar's asking if the white is ice or clouds.
Oh, okay. I love Oscar's following it up with another question. He said, is the white ice or clouds? So the color, let's get down to the basics. The colors are really important. As we're looking at this, we're going to be learning a lot about the Earth by looking at the colors that we're seeing. So in this case, the white can represent clouds. It can be clouds that are up in the sky that are kind of swirling around. So they're in the atmosphere close to the Earth. Now we're on the outside because these satellites are not like just close to the Earth right there underneath the clouds. They're outside of the clouds. So they're giving us this image outside our normal atmosphere. And we're seeing them by the white colors. Now also, if you look up here, look at how different this white color looks compared to this white. Why do you think that is? Now you mentioned snow and ice, clouds. How do you know the difference? Well, one way we can tell is by looking at how solid it is. This looks like pretty solid white. So this would be ice that you're going to find up in the North Pole here. What you're seeing out here would be more of the clouds. And again, look at how they're kind of a swirly shape. They're not quite as defined, whereas we seem to have some very well-defined spaces here. Okay, so we're gathering information about color, knowing that there's certainly areas where there's snow and ice. We've got clouds because of the white color. And then we've got the blue representing the ocean, I'm sure as you all know. But is blue always representing the ocean? Is there anything else on here that is blue that is not ocean? What do you think? Well, I will tell you, I originally am not from Michigan, or not, oh, I blew it. I'm not originally from California. I'm from Michigan. And what I love is that you can see my home state pretty clearly right here. And how can you see Michigan so clearly? What is it surrounded by? Oh, a lot of blue, except that blue is not the ocean. We've got wonderful lakes in Michigan. So we have fresh water. So the blue can be lakes, but yes, all the blue right here seems to be representing water. So fresh water as well as salt water. But because the fact that this is not salt water, that is why I now live in California, because my love was the ocean. So anyhow, we've got that we can learn about the Earth, but there's also something else you mentioned about not moving. What if I changed this and I gave us a little different view? What else could we learn about our Earth? I'm going to make this a little bit more realistic. Now let's see what other things we can observe about our Earth. So now it's rotating. But again, is this an image that is out in space? Is this a live image of the Earth?
We're getting conjectures that it's not live.
So a lot of people are saying this is not live. Because obviously I cannot control the world and how it spins with the touch of my finger. So obviously this is not a live look. But there's also some other things that might tell us that it's not live. Now, it kind of depends on our position as we're looking at the Earth. So if this satellite out in space was right here above the Earth looking down, what time of day are we looking at? And how would you know? So Africa just went on by. It's going that way. Now we're coming up on North America and South America. So when would it be noon? Well, looks like it would be right here because right now this is all lit up. So that would mean that we are looking at daytime right in the middle according to how Earth looks now. But that means that if it's daytime here, what is it going to look like on the other side of our planet? Well, we could probably take a look and let me see if I can change it and make it look, I'm toying around with this a little bit myself here. So now we're having a little bit different shadow right here. And if we wanted to see what's going on with the shadow, I can actually change the position of our sun so that now, where is the sun now? Well, the sun would be on the opposite side. So the opposite side of the Earth is having daytime, and we are on the back side. We're in the shadow of the sun, the shadow of the Earth. But I'm going to pause it here for a second, if I can. Hold on. Let me get, oh, hold on. I thought I could pause it. Maybe I can't pause. Oh, yes, I can pause it. I just need to remember how to use my settings. Stop it right there. Oh, I guess I can't pause it because it goes back to the other side. So again, would be daytime here and nighttime on the other side. But I hope that as it was coming through, you actually noticed something. Did you see anything besides just darkness when it was rotating? Let me try to do that again. Let's change where we're seeing our sun. Hold on just a second. If we make it all dark again, over here, do you see anything else happening? Do you see anything else here? What are these things? Because remember, we're out in space and we're seeing stars that are out here, but they're not moving. What is moving though? The Earth. And so what are these things? What is rotating on the Earth that we would be able to see at night? And in fact, look at the shape. Do you see any particular shape here? This looks oddly familiar to me. Remember we were talking about Michigan and California? Does that kind of look like... Oh, okay. It might be hard to see from because of using moving things on the computer screens. But that was actually the United States going right on by at night. And what's fascinating is that you could even see the outline of our whole entire country because of all the lights that were coming from people. Okay, so some of you were able to notice that. So I'm glad you noticed that. So we're seeing lights where there are more people living. Now, of course, if we were to move things around, say go like, let's see if I can. If I was to go like this and rotate the Earth a little bit, what do you think it would look like if we made it all night? Now, I don't even know if I can on this particular data set. Let's see if we can. But if I could make this all night, would you expect to see any lights down here? Let's see. I'm not seeing any lights right now. And that's because what are we looking at? All right, there's a comment coming in. I'll go ahead and share. If we were looking at the real Earth from above, instead of the model, would we see the clouds moving very slowly? Or would it be impossible to see clouds moving because of the speed? That's an excellent question. And at initial look, we wouldn't see much moving because they do move so slowly in comparison when you're talking about distance. Obviously, if you're really close to something that's moving quickly, it looks like it's moving super fast. But the farther away you get from something and you have more distance and you can see that thing moving in relation to the distance that it's traveling, it looks like it's moving much, much slower. So it might be hard, but if we sat and we were patient enough, we would be able to see movement happening. So great question and something to consider so that we don't just flippantly say, oh yeah, it's not moving. So it doesn't look like anything's moving, so it must be a still picture. But great thinking. But again, we have Antarctica here, right down here. Again, notice the color, colored in white, so it's covered in snow and ice. And of course, if it was dark, we wouldn't see any lights down here because there aren't enough people living down there that would show up at nighttime using electricity and lights. Yes, there are researchers, but not to the level and the extent that we see people living on the rest of our planet. Okay, so we've looked at the Earth, we've looked at the colors. Let's go ahead and look at the Earth a slightly different way. I want you to tell me what you notice about this now. Give it a second. And what do you see? Now, there's a lot more information here than we had on our other, what we call a data set. A data set is just simply, this is what we're looking at now. It's an information set. So it's showing us information in a different way, sometimes using letters, sometimes in numbers, which can be very helpful. You might see some numbers that are moving up here. We've got some letters that are telling us some important information down here. We've got numbers here as well. But remember, we were talking about colors. But I want you to look at the colors here and think about what they represent. Before we talked about the white always being the snow and ice. Now it does look like we still have snow and ice up here, but do we see any clouds?
We're seeing temperature, noticing all the colors.
Okay, so everyone's noticing colors and you're tying it into temperature. So yes, in this case, we're using information, we're using the colors to tell us what temperature. But now we're not just kind of guessing, we actually have a key here that will tell us exactly what those temperature ranges are and what those colors are. But is there anything else that strikes you as unusual or different about this particular data set? And again, let me see if I can get this to rotate for us so you can see more of the Earth than just that one spot. Okay.
Is red, cold is blue.
Okay, so they're noticing the color changes, the color representing the temperature changes. Mrs. Amador's class, you said? Now, I want you to look for any patterns. Do you see any connections to where certain colors are? Because also I want you to notice the temperatures right here, they're in both Celsius and in Fahrenheit. So these are the temperatures I'm most familiar with using Fahrenheit. So you can see 86 degrees, they give you this color right here. Then they've got like 68, 50, and 32. So based on this, what would be the warmest temperature that we're looking at? What would we see on the Earth right now? Using this scale, what color would it be? And you know what? Let's go ahead and tilt this a little bit. I'm going to control the Earth a little bit and how we're seeing it so you can get just a different view right here. So, okay, so what is the warmest color? The warmest temperature is represented by what color here? Okay, so some are saying red. Yes, so the deeper, the darker the red color is, that's going to be the warmer temperatures. What would be the coldest temperatures that you're seeing? What color would that be? And where are we seeing this? So, okay, we're getting blues coming in, yes. Now, would it be the light blue color or would it be the dark blue color? Which one would be colder? Well, yeah, if you're looking right down here, it gets really dark and almost looks black, right? So they're really, really cold, and it only goes to 32 degrees. Why does our data set only go to 32 degrees? Why do you think that is? Any ideas? Because I'm noticing that at 32 degrees, it stops. It suddenly was blue, but then something happens. Okay, so some of you are saying, well, white would be colder. And I want you to think about that. Do you see white on here? Remember how we were looking at the top? We saw some up here near the top. And I think if we look down here, oh, what do you know? There's a little bit of white down here too. But it looks like it's changing. Oh, now what is happening here? Whoa, there is white growing all over the place. Why is that? Because it doesn't even look, wait, that's below 32 degrees. What happens below 32 degrees?
It's freezing point.
Ah, it's freezing point. Yes, that's when water freezes. And it's not going to be liquid water flowing all around the world anymore. It's now becoming ice. So yes, that is why you see the white is going to represent really, really cold, but it's not really going to be the liquid water anymore that's flowing in the oceans. It's going to be ice. And so if we look at the top, we're going to spin the world around. Again, we can see the solid white up here is going to be ice. But again here, it's getting to that freezing point. So it goes from really, really dark blue to this white color once it starts to freeze. But Yasmin made a really great observation. She says, why does the Earth look brown and not pick up color? I want you to think about that. Because wait a minute, if it's really, really cold and icy up here, shouldn't it be really cold and icy here? Why does it not seem to change? In fact, let's look at the other parts of the world. Here's Africa. Now, I do see some color differences. Do you notice the color differences too? So we've got the kind of brownish, yellowish areas down here, but then we've got really green areas here. And looking over at South America, we have a lot of green here. So there is some color difference on the land, but you're right, it's actually not changing at all. Oops, oh, I'm so sorry. I spun the world around in a really fast way. I hope you're not all getting dizzy. Okay, and so again, here looking at North America, you can see this would be like where the mountains are. But again, it's not really changing color. And that's because, as I mentioned before, this is a data set. So this is a particular set of information that we want to look at. And this particular data set really is not interested in what's happening here. Because did you notice, using the other letters and words that are on this data set, what this data set is called? I'll step to the back so you can see it. Right down there at the bottom. Sea surface temperature. And NOAA stands for National Oceanic and Atmospheric Administration. So they're giving us this information. It's a model. So this one is not a real-time image that's happening right now. Obviously, we can't speed up the changing according to my iPad, but we're getting a model of what happens. Except the question is, what is the area of time that we're looking at? How quickly is this happening? Well, it's actually happening. We have some numbers that will, well, when this is playing, maybe I should just play it again, that will change. And you can actually see kind of a time frame for what period of time we're looking at. Because we're not, let me try getting this to move again. It might just be a little bit frozen. But if we look down here, remember at one point we saw that the ice was changing and it was getting really cold around here? Well, that would be, what time of year does it get the coldest? That'd be winter. But when it's winter in the southern hemisphere, what is it in the northern hemisphere? It would be summer. And so when it's winter up here, it's going to be summer in Antarctica. So we're going to flip down, look at Antarctica again, and we're going to notice there's not a whole lot of ice. So at this little snapshot that we're looking at, is this winter or summer here? If there's not a lot of ice, this is going to be summer, which means that it will be winter up here in the North Pole. And that's when we're going to see the most of the ice and snow around here. But it's going to change with the season. So at different times of the year, we'll see this ice shrink and we'll see it expand to cover more areas. All right, but we're not really interested. This part isn't really changing because that's not the data that we're interested in. We're interested in what's happening in the ocean. Now, you mentioned before that the red and the blues are the warm and the cold, but then we've got this color in between. So we've got this green color, and this would be what we might consider to be the temperate waters. So it's kind of on the cool side. If you look down here, it's maybe upper 50s, lower 60s, so not exactly water you want to take a bath in, but it's an important type of water temperature for many different animals and different habitats. In fact, there's a habitat that we have right off our coast here in Southern California. We have a kelp forest habitat. And kelp forests are really dependent on the ocean water being just the right temperature. If it gets too hot, all of this kelp is going to die off and float away. If it gets too cold, it's not going to be able to survive very well here either. So they have a very short, very small temperature range. And so when the temperature is just right, our kelp forest can thrive, and so can all the animals who depend on the kelp forest for their habitat and their home and their shelter, just like some of these animals here, some of my favorite. These are California sea lions, and you can see them enjoying their healthy ocean habitat in the kelp forest. However, when these temperatures get really warm and really high, and I've actually seen this before, where you go back to those areas that used to be full of kelp, lots of kelp forests where they grow all the way up to the surface and they're still growing. So at the surface, there's like this big layer of kelp covering the top of it where it doesn't just look like regular smooth like ocean water. There's like, what's all that stuff on the top of the ocean or on the surface of the ocean? That's all this kelp. You can kind of see it here creating a canopy at the surface. Well, I've been to places where there used to be kelp like this, and I was told, oh, you're going to have to kind of crawl across the top of the kelp at the surface. But when I went, there was no kelp at all. And that's because the ocean water had gotten so warm that that kelp had died off and had floated away. So it was a very different experience than someone who would have been there in the cooler water. So if we look at this, where is that cooler water? Again, Southern California, we're right down here. We must be looking at a time that the water looks pretty cool. But if I was to go back and look at this side, it looks like on the East Coast, it's also pretty cool here. But let me try to play this. Let me, maybe if I reset this, maybe we can see it a little bit better. Oh, it's having a hard time responding to my touch. So I would love to show you how the temperatures might change in the ocean. We talked about how they changed looking at Antarctica, the South Pole and the North Pole. And I'd love to show you. Oh, here we go. Now I can do it. Let's go ahead and maybe stop it at one spot. We're going to pause it from spinning so that we can look, oops, at just North America here. Because we're, oh, I'm so sorry I'm spinning the world around on you so much. But let's look at the temperature and let's see how things change as I play this. All right, now it's starting to play. Also, look at these numbers up here and remember what they might represent. So I'm seeing a 1 now. So 1, 5, and look, these numbers here are only going up to the biggest number I ever see is 31. So these are the days of the month. And oh, look at this. Now look at how different this color is. If I pause it here, well, actually now it looks like this number has changed. It's gone up to 11. And now we see yellow over here, yellow here. California is still a little bit in that cold water region. But we'll let it keep playing out. Now we're up to 12. Oh, and now it goes back to 1. So what do you think that 1 through 12 represents? If these are the days of the week or the days of the month, this is the month. So now we're in April and now we're in May and we can see how things are changing. Do you see this little ribbon right here? This is what's allowing, or this is reflecting the time of year it is where, you know, in August, it's really warm. It's the summer after the ocean's been warming all summer long. And we get this little stretch. This is called the Gulf Stream. It comes from the Gulf of Mexico. But now we're back in December and January, so it's getting really cold here again. And you see now the blue color that's by our coast. So the ocean temperatures are affected a lot by our changing season. But if you were to focus your attention over here and see California never gets that red water that, again, notice how we're starting to see the red on the East Coast? We're not seeing that in California. Now we are seeing it down in Mexico. Why is it so red in the middle of the earth and down here? And why is it always staying cool here and not warming up? Well, hopefully, if you noticed as we were looking at the earth, that red area is in the center. And what is in the center of the earth? That imaginary line we refer to as the equator, where it's the closest, where our earth is the closest to the sun. So it's heating up the most. And then, yes, so the summer months you're noticing, Miss Amador's class is noticing that the summer months are warm and then it starts to cool down again. But again, the warm water is coming from down here. And so did you notice the direction that the water is flowing from the Gulf of Mexico all the way up the east coast of the United States? Whereas on this side, it's always staying cool. And that has to do with the currents. So how the ocean water is moving around our earth. It moves upward on this side. And on this side, we're actually getting cold water that comes down from Alaska, which is why we don't have the really, really warm water temperatures that they do in Florida and some of these Gulf coasts in the summertime. Our water doesn't get quite the same. But we need to wrap up. But I hope that you've enjoyed looking at the Earth from a little bit different perspective and learning how much, or discovering how much we can learn about it by just changing the way we're looking at the data or the information. Using colors tell us a lot, and using times, looking at how the numbers are changing, telling us what point in time we're looking at. So I hope you have a chance to actually explore this on your own, because you can use the SOS Explorer on your own computer, and you can experiment and play around looking at the different data sets as well. But I would love to hear from any teachers that are watching this. How many students do you have watching today? We would love to know how many people were joining us as far as class sizes. So if you would not mind texting us your class sizes to the number right here. You can text us at 562-286-1838. Or you can, of course, you could email us as well. But we'd love to hear what your numbers are. But thank you to everyone who's joined us today. Have a wonderful day, and we look forward to having more Aquarium Online Academy classes next week. Bye, everyone.